Today is honestly an incredible pleasure for myself and the rest of the team because you guys will all be able to tell your grandkids, and however many years that is, that you were there on the day, October 27th, the year of our Lord 2022, the Saturn launched. Today, in about 20 minutes, we are going to launch in front of your very eyes. But until then, I'm going to take you on a little journey of what Saturn is, why we built it, what problems it solves, so you can get just as excited as we are, if not more excited. So, I'm Ansgar Grunseid. I am the Saturn lead. And today we're going to walk through what Saturn is, a new CDN. So, every great product, every great project starts by solving a problem, starts by embracing an opportunity. And we have a monstrous one in front of us with IPFS and Filecoin. Filecoin is an incredible storage network. There's already been assembled 17 exabytes of capacity, 300 petabytes used, but there's a problem. The problem is, where's Filecoin YouTube, right? Like, where is it? The key thing stopping that is fast retrievals. So we can store all of YouTube's data on Filecoin, no problem. We can upload these videos, store these videos. But how can we build an app like YouTube where a video can go viral and 100,000, 200,000, 500,000, a million people can all access this video concurrently? So the way Filecoin has been built is, when a file is stored across Filecoin's network, it's broken into pieces and sharded across storage providers, usually somewhere between 4 to 10, 6 to 10. But that doesn't scale to YouTube scale, to Web 2 scale. So there's a huge opportunity here. How do we unlock Web 3 YouTube? And beyond that, to step forward in time, more close to like where we find ourselves today, there are already tons and tons of people who want to build apps on Filecoin and can't. They're already storing their data in Filecoin, but they can't access it readily. So this is the opportunity that Saturn realizes and embraces. But beyond that, like every other great product, you embrace some sort of insight. There's some sort of wave, something that changed from the past that lets you do something that wasn't possible before. The insight that Saturn's had and the wave that we ride is cryptographic incentives. Cryptographic incentives are rewiring the internet. They're how Filecoin was able to engender a storage network and achieve 1% of the world's storage in less than 2 years. That's an incredible feat. And the reason they were able to do that is not because they sat down with a checkbook and raised a bunch of money to go do that. Is they built a cryptographic network, the network we all work on, and other people came with their storage and their investment, and they added their capacity to the network. And that's what we want to lean into. And so what Saturn is, just like Filecoin and just like other cryptographic networks, is the trustless, permissionless network. At the end of today, anyone around the world will be able to download Saturn software, run it on their server, and join the network without asking for my permission, Patrick's permission, anyone here's permission. And the other key piece of this, of course, is to engender growth. All of this as well, and in addition to all the other Protocol Labs products, it's all open source. It's all community-led, and it's all open source. So, what is the solution? What does Saturn look like? Well, we're going to lean into cryptographic incentives, and we're going to lean into crypto economics to engender this network. And we have grand aspirations for this network. We want this network, Saturn, to scale to millions of nodes globally. And that means that when a user of Saturn tries to access a piece of content on IPFS or Filecoin, they'll be able to find that content closer to them than has ever been possible before. And the other key piece of this is we don't manage this centrally. In the same way that Filecoin has no kind of central organization, there's no boardroom group that gets together to figure out like where the next place to add a storage provider is. We want to build a marketplace for bandwidth, a marketplace for retrievals, and let market principles guide and grow Saturn. So what are the goals? What are we going to do? What are we going to accomplish? Nothing short of building the world's best, fastest, lowest cost CDN, and nothing short of that. And to do that, as I said before, we want to include everyone. So what this means is everybody's hardware, from big beefy servers and data centers to your laptops and your desktops with Station, which is forthcoming. You heard from Miro earlier today about that, all the way to browsers and everything in between. Saturn wants to take a little magical thread and unite all of that hardware into the world's largest distributed network, and then orchestrate that distributed network into the best content delivery network in human history. And what we really want to do here is we want to advance Web3 adoption. There's so many use cases that are just banging at the door to come out of Web3, but they can't yet, again, because a lot of this data is locked in Filecoin and other networks, and we want to emancipate that. And there's one final piece, one final big goal of Saturn that we want to deliver on, and that's to democratize earnings. What does that mean? Right now, you have massive networks like AWS, Google, Cloudflare, and they're the ones that are in one big silo accruing these massive piles of gold. And what we want to do is take that giant pile and divvy it up and distribute it across everybody for contributing their resources to the network. So we want to take that pile of gold and put it back into everyone's pocket. So how do we do that? With a lot of different pieces of the network. So we're going to run through these various pieces here quickly. So the first piece is the retrieval clients. And one of the key insights we've had about how to build a retrieval client in a trustless network like Saturn is verification. It solves this problem. You want to go access a picture of your favorite kitten, and you go to a Saturn node and you say, please give me my favorite kitten. The problem is the owner of that node, oh God, they hate cats, but they really love dogs. So they send you a picture of their favorite puppy. How do you know that that content you got back is the content you requested? And this is one of the key pieces. To grow a trustless network, just like Filecoin, you need to solve this problem. And so the way Saturn solves this problem is by something called incremental verification. And what this means is a client, like a browser, like a game app, et cetera, as they receive content from the network, from an untrusted node in Saturn's network, it incrementally verifies that file to say, this is the file I requested. When you request a SID, you know piece by piece by piece, beautiful kitty pixel by beautiful kitty pixel by beautiful kitty pixel, you're getting the file that you requested back. Now, the next piece, these nodes, what do these nodes look like? Saturn's network is bifurcated in the beginning into two pieces. The first piece is big, beefy servers and data centers. We call these L1 nodes. And so these are servers that are going to be running in edge locations worldwide. And the core of this piece is more or less a little Docker container that we wrote. And you spin up the Docker container, it runs the software, you join Saturn's network, and you serve content to the network, and you remunerate it in Filecoin in return. The second piece is L2 nodes. And this is an interesting piece because this lets us, again, capture humanity's hardware in one network. L2 nodes are much smaller, and they run on desktop devices, exactly like the one I'm giving the speech on now, laptops and desktops. And they're going to be shipped worldwide, and the same beautiful piece of software Miro, who you heard earlier from as well, is working on called Station. And so this means that you will be able to, anyone will be able to download Station and run an L2, a Saturn L2 on their own machine. Now, to orchestrate this all, how do we organize all this into an actual cohesive network? Well, that's in two pieces. The first is what we call the orchestrator, and this is a piece of software that says, how do we match L1 nodes and L2s together such that they can perform and serve, users around the world? So for example, let's say you are in Lisbon, as Jermaine, and you try and access that kitty picture. We don't want you to go all the way around the world to download that kitty picture from someone in California. That's slow. So the orchestrator helps ties all this together. And the other piece is the crypto incentive piece. You need to remunerate and reward nodes in the network for fulfilling requests. And to do that, the very first version we have is all of these nodes, the L1s, L2s, and retrieval clients submit logs, essentially saying, I talk to this other node in the network, and here's what happened. We exchange this amount of data with these kind of timestamps, et cetera. And these logs are fed into the payouts and the earnings. So these logs determine how much you earn in Filecoin as an L1 or as an L2 for retrievals. The more retrievals you serve, the more content you reserve, the faster you serve it, the more you earn. And the other piece here with logs is also anti-fraud. So this is another big piece in any crypto incentivized network. There's going to be fraud. Now, so here's a diagram of what this kind of looks like. So if you see all the way on the left side, and the little white box is a retrieval client, that could be a browser, it could be a native app like Steam, if we're downloading games, it could be a game itself. And what the retrieval client does in the initial architecture is it tries to find the nearest L1 node via DNS. So it submits a request, DNS request, and says, where is the nearest L1? It connects to the nearest L1, and again, an L1 is a server in a data center. And an L1 has a little local cache, and it will check, do I have the kitty picture in my cache? If so, return it immediately. If not, they cache miss to a swarm of L2s around it. If you imagine the L2 swarm as like a little BitTorrent cluster, a BitTorrent swarm around L1s. So these are many more prolific but smaller nodes that provide backup to the L1 nodes. And when an L2 cache misses, so if a request comes in from a retrieval client, the L1 doesn't have it, sends a request to L2s, L2s don't have it, then it falls back to the Filecoin storage providers that host that content itself. So all these layers in the network are caching layers, just like your CPU would have a level 1 cache, level 2 cache, level 3 cache, etc. Saturn has the same caching structure. And you can see the orchestrated and the logs piece off to the side here. Now, the cool and exciting part. We're going to run through a demo. So all this yada, 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 this guy's talking, yeah. Let's see it. So real quick, I want to give a shout out that before launch, we have a bunch of initial launch partners who have been running L1s, and we're about to see that in the demo as these requests will land on some of their servers that they're running. So what we're going to show here in this demo is an escalating performance improvement from IPFS. So we're going to request a SID from the IPFS network, and then we're going to request that same SID from the IPFS gateway, and then we're going to request that same SID from Saturn. And if everything goes according to plan, my laptop won't catch fire, and we'll see everything getting faster and faster and faster. Let's see here. So I am SSH'd, or about to be. The SSH connection's crashed. 1 second. So we're connecting to 2 servers here. The top one is in Sydney, Australia, and the bottom one is in Oregon. And so these are VMs that we just spun up around the world in major cities that we're going to benchmark the latency from the 2 networks. So what we're going to do now here is we're going to broadcast my input simultaneously to both. Danger mode. And here is the asset that we're going to request. So this is just a little 6 megabyte video file of a little, well, you tell me what that is, to be honest. But this is the asset we're going to request. So here, with this first command, we're going to come here, and there's a little IPFS daemon running in these VMs. Is that possible to see it all up there? That's just gobbledygook, isn't it? Let me see if I can, let me see if I can make this bigger. Boy, I can just make anything up, and you guys won't be able to tell if I'm telling the truth or not. Will you? Let me see here. Let's see if that works in iTerm too. That does. Hand that man. You've earned yourself free Portuguese snacks upstairs. Okay, can you guys read that more clearly? Ish? Okay, perfect. So here's what we're going to do. So what this command does, you can kind of read, it clears the IPFS cache, so we're not going to pull the SID from cache. And then it is curling the little local IPFS daemon running on this to go talk to the IPFS network on our behalf, to go request this SID. So here it goes, time spent. The node in Oregon is starting to download the file. The node in Sydney is starting to download the file. And then at the bottom here, it's spitting out the time to first byte. So it took 1.6 seconds for the IPFS network to respond with the first byte of this SID. And the top file in Sydney is still being retrieved. We're going to move on. Okay. So that was the IPFS network in terms of time to first byte. Now, let's test the IPFS gateway. So the IPFS gateway is definitely faster in downloading. And again, this is about a 6 megabyte image here. So here we go, finished, and with a half a second or 530 millisecond time to first byte up top, and it looks like the bottom one hung. There we go. Okay, so you can see the IPFS gateway still has some room for improvement. And again, this is why we're building Saturn, is to improve the speeds of these networks. So now, let's go to the big kahuna. And again, what this is doing is this is talking to Saturn's network. So Saturn's network has more points of presence around the world right now. And when we launch in a few minutes here, as more and more L1 providers jump in and provide capacity to the network, we're going to grow tremendously, 3x, 4x the number of points of presence of any other network soon. That's our hope by end of year. So now let's benchmark, and then boom, done. So as you can see, so what just happened? What did we just watch? Why is this neat and new? You can now access data on IPFS, files on IPFS, and retrieve SIDs, as you just see, 10 times faster than the IPFS gateway and the IPFS network itself. And this will go live here shortly. So you can see the time to first byte in the bottom in Oregon was 43 milliseconds, and the time to first byte up top was at 22 milliseconds. And so you can, yeah, thank you. Thank all these people who worked hard. Yeah, thank you. Thank you. So again, the reason Saturn is outperforming these other services is because Saturn's footprint is larger and can grow larger because it's crypto incentivized to. And this performance will only improve from here. Now, Diego, here we are. So right here, right now, we're going to launch Saturn. Before this moment, you could go and run Saturn software and download on your server and run it, but it would join testnet. What Diego just smashed enter on was you no longer need to have kind of an allow listed Filecoin address to join the production network. So you, yes you, everyone here in this room can now go, and we'll walk through what it's like to set up a node here in a second, can go set up a server, install Saturn, share bandwidth, and earn Filecoin. So, what does that look like? Yeah, thank you. So what does that look like? In the beginning, the hardware requirements are pretty steep, and we're starting them steep for a reason. So you need a 10 gigabit per second upload, 1 terabyte SSD, about 32 gigabytes of RAM. And for your server and running Saturn on it, you can earn anywhere between $0 to $3,000 a month, or about $0 to 600 Phil a month. And again, how much you earn depends on how much you share with the network. The more you share, the more you earn. And as you'll hear from Amin and Maria in a bit, there are other metrics here that Saturn cares about as well, and incents as well. So time to first byte is a huge one. The faster you serve that content, the more you earn. The longer your node is up, and available to the network, the more you earn. The faster you upload data, the more you earn. So all these incentives are baked into the network too. And this is, I guarantee you, your favorite website of 2022, Saturn.network. You can go there and figure out how to register and set up with an L1. So now let's take a look at what running an L1 actually entails. So the first thing you need to do to run an L1 is you need a Filecoin wallet. How are we going to pay you? We need your Filecoin wallet. So you get to set up a Filecoin wallet, and you can use a Coinbase wallet, a Binance wallet, your own hosted wallet. You can do whatever you want. We need a Filecoin wallet. Then you need a Linux server with some of the minimum hardware requirements that we specify here. And you can install and run Saturn via Docker or via Ansible. We'll have more kind of like Chef and other software setups before to help. And then once you get set up and running here, I'll show you some of the things you can take a look at and we'll want to take a look at. So there was a little video. And so once your node joins the network, the page I'm on now is the orchestrator. There's the piece of software that kind of takes a look at the network. And you can see all the nodes that are online right now. And you can see a bunch of these cool gory stats. You can see memory usage, CPU usage, time to first byte, and you can see like the weights, in DNS for how people are routed to those nodes. And then, while also running a node, you have access to a dashboard like this, where you can see your earnings, the amount of bandwidth you've served, the number of retrievals, etc. And then, for this last piece here, once you set up with your L1 and running an L1 and monitoring your stats and checking out your node as participating in the network, you're paid out monthly to your Filecoin wallet. And again, we'll hear more about the payment pipeline and anti-fraud from the ever sagacious and capable Amin and Maria here in a second. Now, where do we go from here? So you just saw the fastest IPFS access content in the history of IPFS. Where are we going from here? So we're here, the beginning. And big things always have small beginnings. So we just launched literally 30 seconds ago. Thank you, Diego. And up next, we're going to test L2 nodes. So again, these are the desktop nodes. We're going to test those in testnet. Come Q1 of 2023 or March 2023, we want to scale the L1 network. And by scale the L1 network, to put things in perspective, we want to have more L1s and more kind of big, heavy points of presence than any other CDN, period. So right now, we got 60-something points of presence worldwide. To put things in perspective, Cloudflare is about 240, Amazon has about 200, et cetera. So we believe we can blow past that. We want to. But that's kind of one of the first order level goals, scale the L1 network. And then we want to achieve sub-second time to first byte for IPFS content globally. And again, this involves getting lots of nodes all over the world, and they have the crypto incentives to grow there. And then come middle of next year, we want to have like the private L2 launch and start having L1 nodes cache miss to L2 nodes. And then we want to integrate all the way here with storage providers at the end of next year. Now, the last little piece here is we are hiring our hungry band of misfits. So if you know anyone who would be interested in being a product manager, full stack engineer, or a senior distributed systems engineer, please find me afterwards. I'd love to speak with you. And then I want to give a big shout out here at the end and be equitable. We'll do a little random sort of everybody. but I'm going to enumerate every one of you. You guys know who you are. So huge shout out, huge congratulations to Joao, Alex, Tomas, Patrick, Ben, Maria, Will, Arsh, Miro, Diego, Julian, Enol, Nadim, Eric, and Amin. Huge shout out to you guys. Huge shout out. And that's it. I'd love to answer any questions you guys have.
All right.
Thank you.
Great talk. Any thoughts on what the steady state might look like for the service providers? I mean, are you envisaging, I don't know, 60% being sort of professionals with their own rigs, and I don't know, 20% small guys in their basement type of thing? Any kind of modeling simulation along these lines, and what does that mean for sort of frequently retrieved data versus the long tail?
Yeah, that's a great question. So the first answer is we await with bated breath to find out how the distribution looks like. Will it be a lot of people who own their own data centers and have capacity and they add it to Saturn? Will it be people who go out and rent the servers and then add those to Saturn? So we want and we aim for people to make a profit running an L1, in a data center, obviously, even when they're renting one. But some data centers are more expensive than others. We don't quite know what the distribution will look like yet. We want it to be a mix. Where that mix will fall out, we don't know. We'll find out.
Thank you.
Yeah, thank you. Great question.
Hi. Just curious, 10 gigabits seems pretty steep. Considering 1 terabyte SSD is cheap, 32 gigabytes RAM is cheap, 10 gigabits is quite steep compared to that. So that's part one. It's why not 1 or 2.5 gigabits or something? And second, why do a differentiation between L1s and L2s? If they could be joined as just L1s, then you probably wouldn't need really steep bandwidth.
Great question. The short answer, to answer your first one about why 10 gigabits a second, is a lot of home residential internet connections now get up to a gigabit and stretch up to a gigabit. And imagine you're an L1 with a max upload capacity of a gigabit a second, and then you're sending a big data file from one L1 to a user who's slurping that down at a gigabit a second. It becomes very easy for one or a few users on fast download connections to monopolize one L1. So we want to avoid that as much as possible. And the other piece of this is we'd rather start high with higher hardware constraints and lower it over time than vice versa. If we start low and find out that just the performance is bad because L1s don't have enough upload capacity, it's a terrible experience to kind of go to users who set up their server and be like, sorry, you're not really tall enough to ride the roller coaster anymore. You already got on, you already put the safety harness on, but halfway through, sorry, you got to get off. So that's not a good experience. So we were going to start high, and then we're going to see. But we're acutely aware that requirement varies differently. They're across the variegated regions around the world, like India and Asia, APAC. Like that 10 gigabit a second is much harder of a requirement to satisfy than like North America and Europe. So we're acutely aware of that. That's a great question, and we're going to see. But we want to start high. And then can you remind me your second question, please?
Why have the difference between L1 and L2? Why not just combine the two? Then you might not need a very expensive L1.
Great question. So the reason those two aren't combined is we want to be able to accept any capacity to the network that we can. So if you had to combine the two, that would happen in a data center. But we want to let people at their home networks contribute to the network and be part of the Filecoin economy. So we made these decisions to kind of break apart the layers of Saturn such that we can onboard hardware in data centers and take full advantage of that, and onboard hardware in people's houses and take advantage of that. And we want to cover everything in between. Does that make sense? Does that answer your question? Great question. Yeah, Molly.
I have a question about the L2 roadmap. So you said L2 testnet in December, L2 beta in March, and then going to GA later. Talk to me about L2 incentives. When does my station node that's currently served 100,000 Saturn retrievals, I believe, at least after I turned it on last night?
Yeah, we directed them all to yours, yeah.
Thank you, appreciate
Please don't shut your machine.
Glad to help. But when does my Filecoin count start to go upward? Do I get to earn some testnet fill or something?
We'd
what does that look
love
like?
to start handing out testnet fill as soon as possible. And before that, paying many people at scale with Filecoin and doing that well is a hard problem. And so we're not sure how and when we're going to start paying real people refill yet. That's probably the biggest question we need to answer, and answer really well, because money's changing hands before launch. So it's not so much technically like the L2 doesn't work and can't contribute to the network and can't fulfill requests. That's groovy gravy. What we need to figure out is how to pay you for that groovy gravy. And so that is one of the last big kind of open, unsolved questions now that we're actively looking into. So I unfortunately don't have a more concrete answer of when, but you raise a great point. Like getting test fill flowing around the test network for this stuff, that's a next natural step.
Gotcha, cool. So that's once we hit mainnet, that's when there's going to be incentives for L2 nodes joining. The plan is not that at the beta timeframe we'll be doing incentives yet in March.
Correct.
Okay,
Correct.
cool. Thank you.
Correct. Does that answer your question, Molly? Great question.
Hi, sort of slightly following on from Molly's question, which is like, so where do you envisage the demand coming from? Like, who are going to be the big CDN customers, and how do you build into that so that we can make money?
Yeah. So great question. So there are a lot of applications already on Filecoin that are storing data that want to retrieve that data quickly. The immediate acute place we see this is with the IPFS gateway. So the IPFS gateway is already serving 3 petabytes of bandwidth every month. And as we just saw in the demo, Saturn is much faster. And so the very first set of customers is going to be meeting those people where we're already proven demand for content off the IPFS network and helping them and figuring out like what is worth paying for, how do we accelerate, what do those apps look like, what kind of websites, things like that. And then beyond that, part of it is we want to build a faster CDN is for Web3 and see what kind of things do people want to build. Is it the Web3 YouTubes that are waiting to build Web3 YouTube because it's just been too fast and just plainly not possible to build something like that because Saturn wasn't a big piece of that. So we have a place to start, and that's where we're going to start, but then we're going to try and figure out use cases after that. We have other ideas as well. So for example, like when nodes join a blockchain, there are lots of snapshots, and these are pretty big and heavy to retrieve, and so like maybe that's another use case. But so we're going to start with what's proven, where the proven demand is, and then really figure that out after that, and talk with people, say what do they want to build the most on Web3 where they just can't until today.
Yeah, hi, I'm wondering about the incremental verification step. So it sounds looks like BitTorrent you mentioned.
Yeah, so the way incremental verification works, what we've built so far, and we'll build client libraries for native apps, and we built one for the browser already. The way it works in the browser is there's a new API called the service worker in the browser. And for those of you unfamiliar with the service worker, if you see a browser tab page, there's JavaScript that runs in that page. It controls, changing the colors of buttons and things like that. But there's a new API that browsers added called the service worker. And it's this like throne that sits beneath the page. It's invisible. It can't control buttons. It can't, play sounds, but it has a different superpower. Its superpower is that it sees network requests that enter and leave the page, and it can do processing on them. So we leverage this service worker such that web pages that want to be accelerated with Saturn and want to have like one-click integration can add a Saturn service worker. And then what the service worker retrieves from Saturn's network is a car file. And then it can incrementally verify that car file and match kind of the hashes of the pieces of that car file as it receives them.
Okay, that's cool. I'm wondering if then the Saturn network has it's tracking all of that eventually, so that L1s, L2s, they will know all these like statistics in terms of the verification steps.
Absolutely. You can't improve what you can't measure, and we're building a performance product. We're building the Ferrari here. So all these things will be tracked, and all these things will be measured. But did I answer your question about the verification? Yeah. Perfect. Great question. Yeah. Thank you, Saturn team.